Welcome back. In this section, we will be talking about the air pollution, air pollutant, and different sources of air pollution, lockdown, its impact on air quality, and subsequent impact on ozone layer in particular. When we talk about air pollution, then what we refer actually is to the presence of pollutant or harmful quantity of different elements or such molecules which deteriorates the quality of the air. When we look at various pollution component, then mostly nitrogen oxide, oxides of nitrogen, oxides of sulfur, oxides of carbon are considered to be primary pollutant. In addition to, there are some secondary pollutant like ozone. Most of these pollutants are originated from different sources like half burning of hydrogen fuel from some natural sources like volcanic eruption, geyser and other sources, as well as from the factories, industries and many other industrial units and plants. So we will see some of these pollutants one by one with special reference to lockdown due to COVID-19. Here we will be seeing mean of emission of some of the um, pollutants before the lockdown as well as mean of some of the pollutants after the lockdown and try to ascertain what is the impact of lockdown on pollution of the atmosphere. One of the major pollutant is nitrogen oxide, which are emitted from engine, industries, and various other sources. When we look at the regional emission scenario of nitrogen oxide, these data are given by NASA and ESA, uh, European Space Agency. These are recorded upper air by various sensors and satellites. The data collected from these sensors have shown that there is a reduction of nitrogen oxide over the period of lockdown in a span of 1 year. If we look at the table, we can see the time. It is roughly almost a 1 year gap, like March in 2019 and March in 2020. So from the data, we see that there is a reduction of almost 20 to 30% in case of nitrogen dioxide. So this is a direct impact of lockdown because the lockdown totally curbed the movement of vehicles as well as running of industries and other such units which emits nitrogen dioxide. Thus, there is a positive impact of lockdown on emission of nitrogen dioxide and subsequently quality of air remains good in absence of nitrogen dioxide. A cartographic representation is given. The data is of nitrogen dioxide emission concentration, mean concentration. The first image is from China. We can see the Beijing and how concentrated the nitrogen oxide emission is in China. So this is two time period. One is in January 2020 and another was in February 2020 in a span of a month. So within this 1 month after lockdown, we can see a drastic improvement in air quality over Beijing. Same thing we can see from Madrid and Barcelona in Spain. Here we can see how these two areas have shown improvement in terms of air quality concentration of nitrogen oxide. The third map here shows Paris and some areas of Germany. Here we can see in a span of 1 year, 19 March and 2020 March, we can see a major difference in terms of emission of nitrogen dioxide. Here again, we can see Italy with Milan for March 19, and in another map March 2020. So here also we can see a major change in the production or concentration of NO2 in Milan. The same we can see, it's a 5 year, 4 year average of nitrogen oxide emission in New York City, and this is in March 2020. So we can see there is also a conspicuous change, or rather reduction, in the emission of nitrogen dioxide. So this whole incident all over the region can be attributed to lockdown. Because of the lockdown, there is reduction of nitrogen oxide and subsequent improvement in air quality. Here is yet another map showing emission of nitrogen and sulfur below. In case of nitrogen, it's a average from 17 to 19, and here it is 2020. So here we can easily see the concentration has decreased over this period. This belt is the mineral belt of India, where there is maximum concentration of industry. So we can easily see the difference. Here we can also see Delhi and Amritsar, Lahore, where in the next map there is hardly any left. Same we can locate Karachi and Mumbai. Similarly, Karachi and Mumbai, we can see reduction in the emission of nitrogen oxide. Coming down for sulfur dioxide, there is a distinct change, reduction in sulfur dioxide due to lockdown impact. Going back to birthplace of COVID, that is Wuhan province, we can see the air quality index during this lockdown period has improved a lot. Here, air quality index for before lockdown and after lockdown is plotted for different stations. In all the stations, we can see the red lines are before lockdown and the blue lines are after lockdown. What does it mean is that the air quality over this period in all the places have improved owing to lockdown. Air quality is an index, more the number, more the pollution, less the number, healthier the air. Next, we can see the major pollutant PM10, 2.5, sulfur dioxide, carbon monoxide, nitrogen oxide. They are showing percentage, decreasing percentage during that period. However, there is a surprisingly new entry, new trend of ozone 3, which shows a increasing trend. This attracts the attention of scientists. Why there is increase in ozone over this period during lockdown? Before going to identify or analyze the reason for increase in ozone production, let us know what is ozone, how they are formed, and how they are destroyed. Formation of ozone and depletion of ozone is a natural phenomena wherein a molecule of oxygen, when it is encountered with ultraviolet rays, that is called UVB rays, this molecule breaks down into two atoms of oxygen. This of these two atoms of oxygen reacts with another molecule of oxygen and gives rise to, in presence of ultraviolet rays, gives rise to ozone 3. Thus, there is ozone formation. In a similar fashion, this ozone again breaks up due to the same ultraviolet rays and What forms is molecule of ozone, oxygen and atom of oxygen. Thus, this is a natural phenomena which goes on hand in hand. However, on ground there is a little difference. Let me tell you, the ozone are found at both high altitude and low altitude. In low altitude it is called tropospheric, at high altitude it is called ozone layer in the lower part of stratosphere. In ground, what happens due to sunlight, presence of sunlight, NOx, that is nitrogen oxides, and volatile organic compounds, they interact with each other along with sunrise and produces ozone 3. Although ozone is not very harmful, but inhalation of it in high quantity may introduce headache and nausea. It is very pungent smell with a blue faint blue color in appearance. However, when smell in very small quantity, it smells good. Study of the ozone and ozone layer is a comparatively new phenomena. Such studies began around 1970s. In the year 1985, a gentleman scientist called Joe Farman for the first time worked on the Antarctica ozone layer and published the article in Nature. The name of article was Large Losses of Total Ozone in Antarctica Reveal Seasonal Chlorine Oxide and Nitrogen Oxide Interaction. In this article, the group observed that ozone level is reduced by almost 40% from 1975 to 1984, and they attributed this reduction to the chlorofluorocarbon gases present in atmosphere. Now, when this there are some sensors on board various satellites, like here in this diagram we can see there are Halley's, then these are the sensor Halley's, Tom's, OMI, OMPS. These are name of the sensor which monitors and tracks the ozone molecules in the atmosphere using satellites. Now, when we look at the thickness, then total ozone, which is measured in the unit DU, we can see 1970 onward there is a gradual shrinkage or decrease in ozone molecule. Finally, around 80 it comes down very rapidly, and around 2000 it reaches the lowest. After 2000 there is slight improvement in the thickness of the layer of ozone. Now this thickness of the ozone layer is measured in a unit called DU, that is Houston unit. The unit says 1 du is equal to the 0.01 mm thick layer of pure air at 0 degree Celsius at 1 atmospheric pressure. Now we can see the average, global average of the ozone is 300 du, that is 3 mm. It is roughly equal to two coins placed one over another. However, when we see the ozone hole, then the average thickness is 1 mm, that is 100 du. That means it is very less in amount, almost one third as compared to the average. So this phenomena is called ozone depletion. However, this can be a natural phenomena or man-made phenomena. As we noted before, formation of ozone and destruction of ozone is a natural phenomena. However, there are some gases which are called ozone depleting substances, presence of which accelerates the degradation of ozone in comparison to the formation. Thus, as a result of that, the ozone layer depletes very fast. Here in this diagram, we can see some properties of ozone. Here we can see UV is 100% absorbed, 90%, 50%. So this zone is where the ozone is present, and this absorbs up to 90% of the radiation. Beyond this ozone layer, the radiation goes unchecked, unabsorbed. That is why the temperature is too high beyond this layer. In the second, we see the presence of variation of ozone. With height it decreases, then at a lower altitude of the stratosphere it increases, it reaches maximum, and again goes down, and finally disappears with altitude. So this zone of maximum concentration of ozone is called ozone layer, whose average thickness is, healthy thickness is 300 and more, and it is called ozone hole as noted before when the thickness comes to 1/3. However, here one thing we need to keep in mind, that ozone hole does not mean a hole in the atmosphere. Rather, it is a layer where the thickness is very low, that is 1/3 of the average of the total. We see here that the ozone depleting substances increases, and by 2000 it starts decreasing. So this trend is visible for all the other substances. Now there is a incident which led to this phenomena. 1970s saw rise in the study of ozone. 1980s saw drastic change in ozone layer, as we noted, 75 to 84. It was a very bad situation. Afterward, in 1987, a concept came up, that is formation of Montreal Protocol, wherein all the countries joined hand together and decided to stop the production of ozone depleting substances, so that ozone layer can be preserved and healed for the greater benefit of the earth and the mankind and other living and non-living things. So because of this protocol, there is a conspicuous reduction in the production and use of ozone depleting substances. The results started showing in a span of 20-30 years. From 2000, there is a positive fall in these substances. So this slope, the aim is that by 2060, this slope will come down to this line level, which is of the 1980s level. That means by 2060, the target is to minimize the loss to the previous level of 1980. It is assumed that during our lifetime, it will be possible for the ozone layer to heal completely by stopping ozone depleting substances. This is one diagram wherein the depth of ozone layer is plotted against different months. From there we can see a pattern that the average fluctuates from high to low during the season of the year, from season to season. However, if we compare all the other data with 2020 data for initial 3-4 months, we see a very disturbing trend. In 2020, the DU, Doston unit, has come down almost to 200 around mid-March. Afterward, it saw slight improvement. Again, when we come down to the temperature thing, then we see the initial 3 months of the 2020 saw very less temperature at upper air. Gradually, after March, the temperature starts rising. So these two trend phenomena has a distinctive impact on the occurrence of ozone layer and depletion of ozone particle in the atmosphere. Now let us see how the ozone layer is behaving over the time. Here in this diagram, we can see the ozone layer over Antarctic. This is Antarctica. So you can see over this is ozone hole. the blue color surrounded with yellow and brown is the high concentration of ozone, and here it is low concentration. So we can see in the beginning the hole was very big. By the end of 19 the hole become little bit improved, the ozone layer depletion was reduced. Again, if we look at the same thing, we find that for the year 2020, 2020, the same thing is observed, wherein there is improvement at current period. In this particular diagram, we see two different time periods, the ozone hole. One is in 23rd May 2020, this is, and another one is in 8th September. So in September, the ozone hole was maximum, which then fairly reduced as compared, because like blue color is more severe, green is little bit severe. So there is a hill as compared from September to May over the period, there is a healing. However, we see a very interesting fact when we look at the ozone thickness in the beginning of this 12 March and 29 April. So what we see it is the ozone hole becomes quite big. In September, in the previous year 2019, it was a big hole. By the end of 19, it healed, and again in the winter season of early 2020, the hole become very big. This is over. This is over northern hemisphere, but by the end of April, this hole becomes very small. That means there is improvement from this period to that period. Now, the people in media and other mediums, social media, have taken given credit to this to lockdown. However, the scientists have opined that this improvement in ozone layer is not because of lockdown, but it owes to some other scientific factor. Now let us see what are the reason for the improvement in the thickness of ozone layer. So from big ozone hole to healing ozone hole, what is the secret behind? Scientists from NASA and European Space Agency and other space research institute have opined that the improvement in the improvement in the quality of ozone layer over the period of during the period of lockdown improvement is not because of the lockdown, but because of a weather phenomena called polar vortex. What is a polar vortex? Let us know what is a polar vortex. Polar vortex is a environmental, or we can say atmospheric phenomena wherein a high uh, vortex is developed over the North Pole and South Pole. In the South Pole, what happens? There is abundance of sea. So in South Pole, this vortex reaches a very high altitude and the temperature drops to very low degree. Sometimes it drops to minus 78 degrees Celsius. This vortex drags the cold air from below and lift them up to the lower part of stratosphere, thus making stratospheric cloud. These clouds, because of updraft, brings with them various molecules of ozone depleting substances. When they During the winter, there is no such change in ozone layer. However, when the sun rays reaches the southern hemisphere, the sun rays interacts with the ozone depleting substances, mostly the bromine and chlorine substances, and reacts with them to destroy the ozone layer. As a result, annually there is ozone hole in the southern hemisphere. However, in the north, the story is little different. Since the north is more dominant with land, therefore the vortex formation is not very strong. Let us see how this vortex formation takes place. You can see this is over the North Pole. This is how the wind rotates, circumnavigates the globe in that region, and they rises above and forms cloud. A vertical cross section shows how cloud, a stratospheric cloud is formed. So this cloud contains the pollutants brought by the updraft of the wind and reaches the stratosphere. As a result, the ozone layer is affected. Now, this year the initial winter months saw drastic drop in temperature. As a result, the vortex became very strong and the upper air temperature was also very cold due to updraft of wind from below and very cold presence of cold wind above. The, there was a large scale formation of ozone depleting substance bearing cloud in the lower part of stratosphere above the Arctic region in north hemisphere, North Pole. Now when the sun rays reached after that around mid of March, the reaction of ozone depletion was very high. As a result, the ozone layer over this part of the globe started depleting in a very alarming rate, as we saw in the previous slide. However, by mid of March, the stock of chlorine, bromine, and other ozone depleting surface started depleting rapidly. Number one. Number two, from the mid of March, the temperature started rising, so the polar vortex became weak. Plus, because of the rising temperature and influx of fresh ozone laden wind from the surrounding below areas, the layer where the ozone depletion took place, the process started going down and gradually influx of ozone rich substance gave rise to healing of the atmospheric ozone layer in that part. Thus, we can say that this depletion of ozone is not because of lockdown. Rather, there are other reasons, as I mentioned recently, that is polar vortex, association of polar vortex, and also photo photo that is something called photo effect of the atmosphere. Plus, scientists have also found that there is a negative correlation between nitrogen oxide and ozone. Less the nitrogen oxide, more the ozone. So that is what is called a secondary pollutant. So this indicates that although there is a decrease in primary pollutant, there may be increase in secondary pollutant. In the last lecture, while talking about the impact of lockdown on environment, I mentioned that there was a negative impact that I left deliberately. Now let us see what is that negative impact is. Now when we look at the COVID and its impact on human health, there is always negative. But in environment, what we see because of this problem, people are wearing masks, gloves, hand sanitizer are used widely like never before. Those who never wore a mask is made to use a mask. Thus, this all thing gives rise to huge amount of biomedical waste. Now, disposal of this is a very big question. In addition, there are PPE kit and other shield and whatnot. all these stress finally will end up in the dump site or into the water bodies. This gonna create a very big problem in future management of this biochemical biomedical waste. Thus, I come to the conclusion of today's lecture. So, what we have seen so far is that because of coronavirus, lockdown was imposed to restrict movement of people from one place to another so that the infection of coronavirus can be stopped through this physical distancing. Now, this result of this lockdown has obvious good impact on Earth's environment because this lockdown has helped the Earth environment to regain, to heal itself during this period because of least human interference with the environment. Secondly, what we saw is that the secondary pollutant like ozone, as I mentioned before, may be a new field of study to understand how reduction in primary do not affect their amount. Rather, sometime reduction in primary indirectly results in increase in some secondary pollutants. So this is a major area of potential research in future. Coming down to lockdown and its impact on ozone layer, we have seen that it is not directly related. Although lockdown has reduced the ozone at the surface, also some of the ozone depleting substances because of the lockdown and subsequent closure of transport and other industries, there is a helping hand. We cannot say that lockdown has healed the ozone layer, but yes, because of lockdown, there is a help in the reduction of overall pollution, which may indirectly help in the healing of the ozone layer. Finally, there is another problem or challenge before the waste management officials, that is biomedical waste. So, disposal and proper uh, treatment of this will be a new challenge in the times to come. Thank you very much. End of this slide, I have given the reference list of references that I have referred to for this study. Those who are interested may refer to those biblio materials available. Thank you so much. Thank you very much for giving me the honor to interact with you all. Thank you all. Have a good day.